Hey, a couple things. Hope everybody's having a good day so far. We are 2 days out from the end of the 6 weeks. So please remember that tomorrow morning, by the end of tutorials, if you have an outstanding assignment that can still be turned in, okay, within the 10-day time frame. If you have a retake you want to take care of, anything of that nature, please come on in. I had several students this morning. I'm sure I'll have several more tomorrow morning. Come on in. I can't guarantee anything can be done, but at least we can take a look and see if your grade is kind of low. We turned in our focus activities today. Please get those in if you've not already done so. I do have some information on next week. They sent out an email yesterday. On Tuesday and Thursday, what are we doing? Okay, we're taking that STAR exam. So if you are not taking the STAR exam, and there's a lot of different reasons why you may not, if you've already passed it, if you're substituting your PSAT score in there, whatever the case, if you are not taking it either of those 2 days, then it's a late start day for you. So the tardy bell for classes will be ring at 1:35. So that means the normal bell will ring at 1:30. You'll start class at 1:35. The classes will be about 30 minutes. So on Tuesday afternoon, you'll go to periods 1 through 4. On Thursday afternoon, you go to periods 5 through 8. So I will not see you next Thursday afternoon. So what I'm thinking is that because that day is going to be separated over two, we'll probably have some kind of exit ticket over binomial theorem. I'll probably have you expand binomial for me. Go ahead and find me a specific term. Something you should be able to do, I would say, within 30 minutes. Okay. And something else, what's due on Friday? Okay, the homework. You currently have the series homework. So with everything I've been able to do today with binomial theorem, we should have no problem wrapping up the binomial theorem lesson by Friday. In fact, we would already be done with it tomorrow if it wasn't for district assessment, which we have to take because of reasons. I believe I mentioned yesterday a majority of it is material we haven't talked about. Did I mention that? Okay, so I apologize about that. It's just something that we have to do. Give it your best guess. If you know anything about conics, you should be okay. It's not taken for a grade, so don't worry about it. There are 7 questions that we have been able to talk about that hopefully you'll be able to answer, so we'll take a look at those. But that's pretty much what's going to be happening in the near future. Anybody have questions? Anything that's happening?
What was that? Did you say that you can substitute your PSAT score for STAR and just not take the STAR test?
Well, now I saw that on the email they sent for the English. I don't know about the others because it's got it broken up into grade level, and I think it's only if you are a certain grade level, like 9th or 10th, that you can do that. Yeah, so, yeah. Okay. So I don't think as a junior or senior you can do that. But, no. Okay.
STAR sucks.
It's another state test in a long line of state tests. I go all the way back to TOS. Tax was around for a really long time. Yeah. So, I mean, STAR won't be here forever, but there will always be something to take its place because people like the idea of state exams. I'm not a big fan of them, but I'm just a little fish in the big pond. So.
What do you suggest to replace them?
Well, honestly, I don't think it's needing to be replaced at all. I mean, we used to have it under tax where even if you passed the class, but you may have failed the test over that class, that you couldn't receive your diploma. I don't know. Do some of you go back far enough to remember that? Okay. I definitely didn't like that. I mean, it got to the point with tax that we were pretty much not teaching the curriculum what you needed. We were basically teaching you how to take the test. We were going over strategies and just reviewing, and that's what it really came down to. And I mean, that's not going to benefit you, I don't think, in the long run. Luckily here, we don't have a STAR exam. I mean, even if we did, I would probably spend a little time reviewing, but that wouldn't be the main focus, personally. But I don't know. It is what it is. Okay? All right, any other questions? Okay, well, we were talking about the binomial theorem yesterday, expanding binomials, and we talked about and worked an example using Pascal's triangle. Pascal's triangle is very useful in getting the coefficients for your expansion. The only trick, remember, at the very top, you start counting with 0, then 1, 2, 3, 4, and you keep going. In order to generate the following rows, you take the sum of the consecutive terms to get the one below it. Okay, so we looked at that, but then we finished yesterday by looking at a combination. Okay, so let me kind of just start over at the beginning again. Let's review this, and we'll go ahead and put it into practice. I think we already did one. Didn't we solve the combination of 7 and 4? Okay, all right, so we'll get the opportunity to do another one of those in just a moment, but what does the exclamation point mean in mathematics? That's a factorial. Okay, so in factorial, this is n times n minus 1 times n minus 2, dot, dot, dot. Basically, you're multiplying a huge product. You're starting with the first value given, but you're looking at the decreasing order of the whole numbers, all the whole number values that came before yours. So if I were to say 5 factorial, that actually means 5 times 4 times 3 times 2 times 1. Okay. Now, what we're going to go ahead and use is a combination. And you may or may not be familiar with that. Really, factorials are going to show up more with combinations and permutations than anything else. And if you're not familiar with those, that's fine. But these combinations can help us figure out what the coefficient of a certain term in your expansion should be, just like Pascal's triangle can do. So the formula, okay, is n factorial divided by n minus r factorial times r factorial. And you'll notice this combination here has 2 subscripts. The first is always n. What does n represent? Okay, it's always the original power you're wanting to place on your binomial. Okay, now the way we're going to go ahead and define r, okay, r is the second term's power. That's going to come in really useful to us. Well, when it comes to the terms themselves, up until now we've been calling them a and b. Well, as you go through your terms, the powers on a will do what? They descend. Okay, they get smaller, while the powers on b will ascend. They're going to get bigger. So look at the combinations we have here in the expansion. We're raising it to the third power, so we have a cubed b0, a squared b to the first, a to the first b squared, a to the 0 b cubed. So it's doing exactly what we just said. But look at the combination here, each one of these. You'll notice in this case n would equal 3 because I'm raising it to the third power. So we have the combination 3, 0, combination 3, 1, combination 3, 2, combination 3, 3. What is happening that's consistent for each of those? Yeah, n. That first subscript, the power you're starting with, that remains the same. But with r, you always start with 0 and you increase. Basically, you're going to start with c in 0, and you're going to go all the way through c in n. Fake news. Sorry, I couldn't resist. C in n. Sorry. Okay. I really should stop doing it. But anyways, you'll see in just an example in a few moments when we go ahead and do that. All right, but one other thing I want to go ahead and point out, I said the fact that r is going to be the second term's power. We'll take a look. When r is 0, you have b to the 0. R is 1, b to the first. R is 2, b squared. R is 3, b cubed. Okay, that's always going to remain the same. And it's all about patterns. As long as you know the patterns, this is going to be real easy for you. Okay. So it says down here in the example above, notice that for the first term r equals 0, second r equals 1, and third r equals 2, what I was just showing you. In general, to find the binomial coefficient of the kth term in an expansion of the form a plus b to the n, use your combination formula, but let r equal k minus 1. So I'm going to go ahead and show you a couple of different ways to do this. One way is to just say exactly what term I want. But I'm only going to show you one of these because I feel it's necessary that you see it. But from past experience, I'm going to go ahead and move on to problems. Instead of saying find me the third term, find me the 7th term. I'm going to go ahead and tell you the term with what power combination I want. Okay, because in the first one, I've noticed that people do tend to get confused if I say find me the 5th term. Okay, some people would say that R equals 5. Some people would say that K equals 5. And I just want to kind of avoid that confusion. But let me go ahead and walk you through the actual process. Find the 5th term of A plus B to the 7th. Okay, so if I'm wanting the 5th term, that means K equals 5. K represents the term number that you're going for. Now, was there just an expression we were given to help me find R? Remember, R equals K minus 1, right? So 5 minus 1, we know that R is 4. So I'm looking for the combination. We know that R is 4. What's N? N is 7. Remember, N is the power you're placing on the original binomial. That's the expansion we want. Okay. And you remember yesterday, this was the one that we actually worked together. Does anybody remember what we got as an answer? Remember, we got 35. So for the people who weren't here yesterday, let me go ahead and see if I can help catch you up. That's N. Remember, that's R. The formula says N factorial over N minus R factorial, R factorial. That's the formula for a combination.
Hey. Sorry to interrupt, but I know that we're going to pass, but Commander, when it's in like assurance, do you think you could just sign this?
Oh, you just want to sign it?
Yeah, please.
You got a pen?
Sorry for the...
No, you're fine. Do I just sign?
Like right there. Yeah, under pre-pass.
Okay.
Yeah.
Okay. There you go. And yeah, that's from before, right? Because I'm about to say we got that up.
Yeah.
Okay.
We explained it to him.
Okay. There you go.
Thank you
No
so
problem.
much.
I'm sorry. What did you say?
Volleyball finance.
Oh, volleyball. Oh, okay. 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 So let's go ahead and plug in. Let's see, what we had was n factorial, so 7 factorial over, and here's what I like to do. I just simplify as I plug in. So 7 minus 4 will give me 3 factorial, and I have 4 factorial. Okay. Is everybody okay with how I plugged in? So we ultimately will get 35. Now you can completely simplify 7 factorial, multiply 3 factorial times 4 factorial, divide them out. But what I showed you yesterday, I would go ahead and simplify if possible. I'd say 7 times 6 times 5 times 4, and I would stop there because I have a 4 factorial in the denominator, and those can cancel. Because each one of them is 4 times 3 times 2 times 1, so all of those pairs can go. Now, somebody did ask me in first period, could I have said 7 times 6 times 5 times 4 times 3 and canceled out the 3's instead of the 4's? Could I have done that? Now, very important, would I have still gotten the same answer? Yes. I personally just like to simplify the largest one because it takes a lot of work off your plate. In fact, what is 7 times 6 times 5? 210. 3 factorial? 6, 3 times 2 times 1. And see, that's where we got my 35 from. But now, that's just the coefficient. Now, we know that's not changing because these coefficients are both 1 on my terms. So we still need to know what power combination I'm going to have on A and B. In fact, can anybody help me out? Do we already know one of them? Which one do we know, A or B? Remember, was there something I said about that second subscript? There you go. R is the power on your second term. Remember, we just looked at that in the pattern? So I know this would have to be 4. So that means A has to have what power? So why would it have to have 3? What was one of the patterns we looked at yesterday? There you go. The sum of those powers should always be the value of n. Okay. Now that one's not too bad, right? Pretty straightforward. Okay. Let's look at one that's a little bigger. Find the coefficient of the x to the 7th y squared term from 4x minus 3y to the ninth. Now, why is this one going to give me a coefficient that's way larger? What's different about this binomial than the previous ones? These actually have coefficients other than 1, so we have to include those. So think about the first term, that's a. The second term is still b, but if you're subtracting, it has to be negative 3y. We have to include the negative with that. Okay, so let's go ahead and do this. Let's start with our combination. Okay, did we know n? That's 9. Remember, that's the power that we're wanting to expand my binomial. Now here, remember, we're not trying to get the full answer. We just want to know one single term. Okay, what's r? How do we know? There you go. Remember what we just said, the coefficient, or excuse me, the power on that second term is r. So what we're trying to figure out is the combination of 9 and 2. Now I'm going to go ahead and apply my powers to the terms that I have. So instead of a and b, we now have 4x and we have negative 3y. Can anybody tell me what power should go on 4x? It's got to be 7. Remember, we want the x to the 7th y to the squared term, so that has to be 7, that has to be 2. So can everybody see now why we're going to end up with a much larger number? Okay, we have to raise those coefficients to their respective powers. Okay, so let's run through this. I want the combination of 9 and 2. So that would be 9 factorial over 7 factorial, 2 factorial. Everybody okay where the 7 came from? Okay. So this would be 9 times 8 times 7. 7 factorial, 2 factorial. So I'm going to cross out the 7s. That's a huge product that we're getting rid of. So 9 times 8 divided by 2. 36. Okay. Now remember, this 36 only represents the combination. I still need to go ahead and figure out what the other coefficients are going to be. So I have 36 times, that's a horrible looking 3. Let me do it again. Much better. Now, what is 4 to the 7th power? $16,384 x to the 7th times now negative 3 squared. 9y squared. So see, we are going to end up with the x to the 7th y squared term, but we need to multiply 36 times 16,384 times 9. Does anybody have that? It's going to be in the millions. Okay, so that is 5,308,416 x to the 7 y2. There you go. There you go. Okay, questions? Okay. Now, let's go ahead. Let's work a problem. Now, the only issue I'm seeing with this resource is the problems they go ahead and give you for the expansion, like x plus 1, x minus 1. I mean, they're really simple binomials. The only one that really is kind of nice is this 2x plus 5 cubed right here. So let's go ahead and work this one. Okay, let's skip to number 8. Now, I'm going to go ahead and set it up both ways. I'm going to set it up using Pascal's triangle, and then I'm going to set it up using the combinations. And then you guys are going to decide which one you want me to finish solving. Okay, so let's go with Pascal's triangle. What row should I look at? I should look at the third row. So I'm going to go back to Pascal's triangle. Here's, remember, we always start 0, 1, 2, 3. So I'm looking for the coefficients 1, 3, 3, 1. Everybody with me? Okay, so I'm going to come back over here. Okay, if I can find my spot. There we go. So using Pascal's triangle, I'm going to go ahead and say 1, 3, 3, 1. Now, why am I leaving so much space in between these? Yeah, because we have to account for those terms. A is equal to 2x and B is equal to 5. So remember, those combinations, A always starts with the power to n and decreases. B starts at 0 and increases. So times 1, I should put 2x cubed, 5 to the 0. Now, right after 3, this is where I'm going to put 2x squared, 5 to the first. Remember that pattern we were talking about yesterday? The A powers decrease, the B powers increase. Okay. So what would follow the second 3? 2x times 5 squared. Okay. And then what would follow that last one? Yeah, just 5 cubed. Because you would have 2x to the 0, 5 cubed. And again, I'm still plugging in those terms with the 0 power just because I'm still trying to emphasize the pattern. Okay, if you already feel comfortable, you don't want to put the 0 power in, please don't feel like you need to. And now from here, I would just simplify, and I'd be able to get my answer. Okay, let's say I wanted to go ahead and solve this problem using the combination. Okay, well, I'm going to go ahead and do it just right below. Remember, you're going to start with a combination of n to 0, and you're going to go from a combination of n to n. Well, what is n this time? Remember, n equals 3. It's that original power, right? So my first combination should be 3 and 0. What would the second combination be? 3, 1. Remember the pattern that we saw? N stays the same for the combination. R starts at 0 and increases until we get to n. So what would the next combination be? 3 and 2. And then finally a combination 3 and 3. And that's what I'm referring to when I say n and n, you get to the same values. Well, why do you think I left some room here? Yeah, I still have to take care of those two terms. I have to plug in the same combination. So this one would be 2x cubed, 5 to the 0. This one right here would be 2x squared, 5 to the first. Get that little plus in there. This one would be 2x to the first, 5 squared. And then this one would be 2x to the 0, 5 cubed. Okay. Now, it doesn't matter how you go ahead and solve these. Pascal's triangle, combination, you're going to get the same answer. Okay. It does not matter to me. So I'll probably just give it to you on an exit ticket, a quiz. I'll go ahead and say, expand this to the 10th power, whatever. Okay. If you want to use Pascal's triangle, feel free to use so. If you want to use combination, feel free to use so. The only thing I would encourage you to do, if you're going into calculus, I would suggest you probably do what? Get more acquainted with the, I would say, combination. Okay. But there you go. So what would you like me to solve? Because it's going to be the same answer both ways. Do you want me to solve Pascal's or combination? Combination. In fact, that's probably a good way because take a look. Let's find the combination of 3 and 0. So if I were to plug it in, that would be 3 factorial over 3 minus 0, 3 factorial, 0 factorial. There's the formula. Now those 3's are going to cancel, but what is 0 factorial? Remember, that is 1. Okay, so this is 1. And you'll notice, what was the corresponding coefficient from Pascal's triangle? It was 1. Okay, what do you think I'm going to get if I simplify the combination of 3 and 1? I'm going to get 3. Okay. See, these combination formulas, they're going to give you those values from Pascal's triangle. That's why it doesn't matter which one you choose to use. Okay. All right. So let's go ahead and see here. If this guy's going to give me 1, well, that would be 1 times, well, 2x cubed would be 8x cubed times 5 to the 0. That's just 1. So the first term in your answer should be 8x cubed. Okay. Now, the combination of 3 and 1 is 3. Does anybody want me to plug in the formula and show you that? Okay. What is 2x squared? That would be 4x squared, right? Times 5. So what would the second term be? 3 times 4 times 5, 60 x squared. Plus, what is the combination of 3 and 2? Yeah, it's 3. Okay, Pascal's triangle. Again, does anybody want me to show that? Okay, then 2x to the first, that's just 2x times 5 squared, 25. So 3 times 2 times 25. 150, and then we have the x. Perfect. And then plus, here's our last one, combination of 3 and 3. Oh, heard somebody say it. That would be 1. 2x to the 0 is 1, and what's 5 cubed? 125. There we go. How are we doing? Okay, you ready for one on your own? Okay, Jasmine says, yes, I am. Let's do it. All right. So it's okay. Remember, just take it one term at a time. Remember your patterns. Now, this is not in your notes because I actually wanted to give you a decent one that's going to help you out. Let's see, where was it? Right here. There we go. 3p minus 2q to the 4th power. I want you to completely expand this. Now, how many answers, or how many terms should you have in your answer? 5. Remember, it's always one more number of terms than the value of n. Okay, so 3p minus 2q, okay, to the 4th. Excuse me. All right. So I'm thinking probably 4 or 5 minutes, okay, for the first one. Okay. Let me go ahead. Start with 4. Now, remember, you have a choice. If you want to use Pascal's triangle, you're going to look at row 4. Okay? Or you can solve it using combinations. When the time comes, I'll go ahead and solve it however you folks decide. Now, is there anything else you should notice about your expansion? Maybe about the signs? Guaranteed we know they're going to what? Why will they alternate? Because you got a negative. So you'll have positive, negative all the way through. You might need help getting started. kind of feel at times like this when I'm recording and there's a pause because you guys are working. I should have some sort of maybe elevator music or filler. They used to back in the day, but I don't think they do anymore.
Usually they like glass, so that's supposed to entertain.
Glass is supposed to entertain you?
Like, yeah.
There you go. And people who are afraid of heights can freak out that much more. So.
They need to make the floor though, like plexiglass with a little bit of glass. So you can see
There we go.
excitement going up and down.
Well, I don't know about elevators, but don't they have that platform at the Grand Canyon that you can walk out onto it and you can see straight down?
Some guy died the other day.
Some guy died the other day. I heard about that. Wasn't he taking a photograph or something? And I don't know exactly the circumstances.
He went by the lookout, but I don't think
He wasn't on it?
Yeah.
That's horrible. That's ugh.
Someone died like
Good Lord. Okay. All right, so that was 4 minutes. Okay, is there anybody who has gotten the 5-term expression? Anybody believe they can tell me the coefficients? Okay, so one hand going up. So while you guys keep working, Satish, don't worry about the combinations. We'll get those together. But what'd you get for the coefficients? Yeah, just say it. Okay, and what he said was he started with 81, then he said the negative 216, positive 216, negative 96, and the constant, last one, 16, right? How many people are getting those coefficients? Okay, good, 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 good. Now this is, are we ready to go ahead and see the actual answer? Sure, why not? Okay. So that is what we should be getting. That is absolutely correct. Okay, so let me at least go ahead and write this out. What would you prefer me to use? Pascal's triangle or a combination? How many people want Pascal's triangle? 1, 2, 3, 4. Okay. How many want combination? So several more hands. Okay, let's do the combination. So because n equals 4, I'm going to go ahead and say the first combination 4 and 0. But now I'm going to go ahead and incorporate those two terms. So this is going to be 3p to the 4th negative 2q to the 0 plus, what's the next combination? 4 and 1. Remember, the n value remains constant. It's r that goes from 0, 1, 2, 3, all the way to n. And then the combinations here are just like we've been looking at. This would now be 3p cubed negative 2q to the 1st plus combination 4 and 2, 3p squared negative 2q squared plus combination 4 and 3. This is now just 3p to the 1st negative 2q cubed, and our final one, the combination 4 and 4. 3p now has a power of 0, negative 2q to the 4th. Okay. See, it's all about the patterns. If you know what's going to happen, you're just filling in the next term. Okay, one step at a time. So if I were to take any one of these, like the first one, the combination of 4 and 0, well, that's 4 factorial over 4 minus 0, 4 factorial, 0 factorial. What does that equal? That's 1. So 1 times, what's 3p to the 4th? 81p to the 4th. Negative 2q to the 0 is 1. So that's where we got our first term. Okay, and then you just go right down the line. You just simplify. Combination of 4 and 1. So that would be 4 factorial over 4 minus 1, 3 factorial over 1 factorial. Okay, well, we can simplify this. 4 times 3 factorial, 3 factorial, 1 factorial, those cancel. So that is 4. What's 3p cubed? 27p cubed times negative q to the first, so that's just negative 2 cubed. And you'll notice 4 times 27 times negative 2, there's your negative 216. And then, of course, you have the p cubed and q. Okay. Now, I know it seems like it's taking a lot of time, but the more you work these, the more comfortable you get, it's actually going to start to go a lot faster. You'll actually be pretty surprised at how fast you can expand large power binomial. Okay. Does anybody want me to run through any of the other 3? Show how we got those? How many people got this correct? That's good. That is more people than any other class today. That's really good. Okay, excellent, excellent, excellent. Well, that is as far as the other 2 classes got. So I'm going to go ahead and stop there because I want to go ahead and show you a video real quick. Okay, don't worry, it's math related, so it'll be fun. Okay. Now, the one question I have that's coming up, and I can probably go ahead and put a link to this in the website as well, but a question a lot of people have been asking is, why is 0 factorial equal to 1? Okay, so I found a video. I mean, I could go ahead and derive it for you, but this guy actually does a pretty good job, so